Welcome to an extraordinary journey beyond the stars. In this captivating video, we'll delve into the tantalizing question that has intrigued humanity for centuries. Is there life beyond our own planet? Join us as we explore the realms of possibility, dive into the latest scientific discoveries, and ponder the astonishing diversity that might exist on distant worlds. From the depths of alien oceans to the barren landscapes of distant exoplanets, prepare to expand your horizons and imagine the unimaginable. Get ready to embark on a quest to uncover the mysteries of life on other planets. Life is a complex and organized system that exhibits attributes such as growth, reproduction, energy utilization, and response to stimuli. On Earth, life is thought to have emerged through a process called abiogenesis, where simple organic molecules combine and evolve over time, eventually giving rise to more complex organisms through natural selection and genetic variation. The exact mechanisms of how life originated remain a subject of ongoing scientific investigation. Life is a complex and fascinating phenomenon that has developed on Earth thanks to a series of conditions and processes that have made it possible. However, Earth is not the only place where life could exist, since there are many other planets in the universe that could harbor it, although perhaps in very different ways from the ones we know. In this text, I will explain how life can arise on other planets and what implications it would have for us and for the knowledge of the cosmos. To understand how life can arise on other planets, we must first define what life is and what requirements it needs to originate and maintain itself. Life is a state of matter characterized by complex organization, a capacity for self-preservation and self-regulation, a capacity for reproduction and evolution, and a capacity for interaction with the environment. These characteristics imply that life needs a source of energy, basic materials to build its structures and functions, and adequate environmental conditions for its development. On Earth, the main source of energy is the sun, which provides light and heat to photosynthetic organisms, which in turn generate oxygen and organic matter for other living beings. The basic materials are the chemical elements that form organic molecules, such as carbon, hydrogen, oxygen, nitrogen, phosphorus and sulfur. Finding life on other planets would have profound implications for our understanding of the universe, our place in it, and our relationship with other living beings. Here are some possible implications of such a discovery. Scientific implications. Finding life on other planets would challenge and expand our knowledge of biology, chemistry, physics, and astronomy. We would learn more about how life originated, evolved, and adapted to different environments. We would also learn more about the diversity and complexity of life forms, and whether they share any common features or characteristics with life on Earth. We would be able to test our hypotheses and models of planetary formation, habitability, and biosignatures. We would also be able to explore the potential for communication and cooperation with other intelligent civilizations, if they exist. 12. Philosophical implications. Finding life on other planets would raise fundamental questions about the nature and meaning of life, the origin and purpose of the universe, and the role and responsibility of human beings. We would have to reconsider our assumptions and beliefs about ourselves and our place in the cosmos. We would also have to confront the ethical and moral issues that arise from interacting with other living beings, especially if they have different values and cultures than ours. 3. Religious implications. Finding life on other planets would have different impacts on different religions, depending on their doctrines and teachings. Some religions may welcome the discovery as a confirmation of their faith and a sign of God's creation. Others may reject or deny the discovery as a threat to their authority and legitimacy. Some religions may adapt or reinterpret their scriptures and traditions to accommodate the new reality. Others may face internal conflicts or schisms among their followers. The emergence of life on other planets is a fascinating and complex topic that involves many factors and uncertainties. Some of the possible impediments to the origin and evolution of life on other worlds are environmental impediments. The conditions of the planet's environment, such as its temperature, pressure, radiation, chemistry, and geology, can affect the likelihood and diversity of life. For example, planets that are too close or too far from their stars may be too hot or too cold to support liquid water, which is essential for life as we know it. Planets that lack a protective atmosphere or magnetic field may be exposed to harmful cosmic rays or stellar flares that can damage or destroy organic molecules. Planets that have a stagnant or volatile crust may not have the necessary geochemical cycles or energy sources to sustain life. 12. Biological impediments. The processes of life itself, such as its origin, evolution, and adaptation, can also pose challenges for the emergence of complex life forms. For example, the origin of life may require a rare or improbable combination of events or ingredients that are not easily replicated elsewhere. The evolution of life may be constrained by the availability of resources, the competition among species, the occurrence of mass extinctions, or the presence of biological barriers. The adaptation of life may be limited by the speed and direction of natural selection, the complexity and robustness of biological systems, or the environmental changes and stresses. 12. Intelligence impediments. The development of intelligence and civilization, which are often considered as indicators of advanced life, may also face difficulties or delays on other planets. For example, intelligence may not be a universal or inevitable outcome of evolution, but rather a contingent and rare phenomenon that depends on many factors, such as brain size, social structure, environmental challenges, and cultural influences. Civilization may not be a stable or sustainable state of affairs, but rather a fragile and transient phenomenon that is prone to collapse or self-destruction due to factors such as war, disease, pollution, resource depletion, or climate change. There are some exoplanets that could support life, depending on their distance from their stars, their size and composition, their atmosphere and climate, and other factors. Some of the most promising candidates are Proxima Centauri b. This exoplanet orbits the closest star to our solar system, Proxima Centauri, which is a red dwarf. It is located in the habitable zone of its star, meaning that it could have liquid water on its surface. However, it is also exposed to intense stellar flares and radiation, which could make it hostile to life. 1. Kepler-452b. This exoplanet is often referred to as Earth's cousin, because it is similar in size and orbit to our planet. It orbits a Sun-like star, Kepler-452, in the habitable zone. However, it is also 60% larger than Earth, which could mean that it has a thick atmosphere and high gravity, which could make it difficult for life to thrive. 1. TRAPPIST-1e. This exoplanet is one of 7 planets that orbit the star TRAPPIST-1, which is a very cool and dim red dwarf. It is the most Earth-like of the 7 planets, with a similar size, density, and radiation exposure. It also has a moderate temperature and a possible water cycle. However, it is also tidally locked to its star, meaning that one side always faces the star and the other side is always in darkness, which could create extreme weather and climate variations. 12. Exoplanets are planets that orbit stars other than our Sun. We detect them using various methods, such as transit method. This method measures the dimming of a star's light when a planet passes in front of it. This can tell us the size and orbit of the planet. Most exoplanets are found using this method, especially by the Kepler Space Telescope. 12. Radial velocity method. This method measures the waddling of a star caused by the gravitational pull of a planet. This can tell us the mass and orbit of the planet. This method was used to find the first exoplanet around a Sun-like star in 199512. Direct imaging method. This method takes a picture of the planet directly by blocking or reducing the glare of the star. This can tell us the color and temperature of the planet. This method is very challenging and only works for large and bright planets. 134. Microlensing method. This method uses the bending of light by gravity when a star with a planet passes in front of another star. This can tell us the mass and distance of the planet. This method is very rare and only works for distant planets. Are there any missions to find extraterrestrial life? Yes, there are several missions planned or proposed to find extraterrestrial life, both within and beyond our solar system. Some of the most notable ones are Mars 2020 Perseverance rover. This mission, launched by NASA in 2020, is currently exploring the zero crater on Mars, looking for signs of ancient microbial life and collecting rock and soil samples for future return to Earth. 1. Europa Clipper. This mission, planned by NASA for launch in 2024, will orbit Jupiter and conduct multiple flybys of its moon Europa, which is thought to have a global ocean beneath its icy crust. The mission will study Europa's geology, chemistry, and potential habitability. 2. Dragonfly. This mission, planned by NASA for launch in 2027, will send a rotorcraft lander to Saturn's moon Titan, which has a thick atmosphere and a rich organic chemistry. The mission will explore various sites on Titan's surface and subsurface, looking for prebiotic or biotic processes. 3. James Webb Space Telescope, JWST. This mission, a collaboration between NASA, ESA, and CSA, will be launched in 2021, and it will be the successor to the Hubble Space Telescope. The JWST will observe the infrared spectrum, and it will be able to study the atmospheres of exoplanets, searching for possible biosignatures such as water, oxygen, methane, and other gases. Large UV/optical/IR surveyor, LOVER. This mission, proposed by NASA for launch in the 2030s or 2040s, is a concept for a large space telescope that would have a primary mirror of up to 15 meters in diameter. The LUBR would be able to directly image Earth-like exoplanets and characterize their atmospheres and surfaces in detail. Breakthrough Starshot. This project, funded by the Breakthrough Initiatives and led by Yuri Milner, Stephen Hawking, and others, is a visionary proposal to send a fleet of tiny spacecraft propelled by powerful lasers to the nearest star system, Alpha Centauri, in search of habitable planets and possible life. The project aims to achieve this feat within this century. That's all. Bye.